Today we'll talk on lesson 5, that is migrating VMs with vSphere vMotion. Okay. However, maybe you are doing this
Okay.
exercise already, but yeah, let's go a little bit deep dive and see that. So we will cover how vSphere vMotion works, verify the vSphere vMotion requirements, and migrate the virtual machines using vSphere vMotion. Okay. Well, when we say vSphere vMotion, uh, migrating or moves a powered on virtual machine from one host to another host. That's we called as an vSphere vMotion. So it will improve the overall hardware use, continuous VM operations while accommodating the scheduled downtime, especially for maintenance, primarily the activity when we are doing some patching activity, update activity. So we need to be free up that node during that time when any kind of upgrade happen, whether that is your hypervisor upgrade or it is your hardware upgrade. Or secondarily, if there is some hardware failure have been detected, so for that time we have to put on a host in maintenance mode. Okay. Then vSphere DRS take the advantage of vSphere vMotion to balance the VM across the hosts on the basis of resource requirement on each and every host. All right. So that's why we do the vMotion. So from requirement perspective, we'll talk about accessibility of all VM storage 128. Current migration can be happen over the VMFS data store, and at least we prefer to give 1 GB bandwidth network. So with throughput of 250 Mbps for vSphere vMotion. Concurrent migration are to 4 1 Gbps and 8 on 10 Gbps network. So for better performance, give a dedicated port group and a separate port group for the vSphere vMotion traffic. And CPU compatibility perspective, CPU features on the both and source targets should be compatible. Otherwise, you'll get an error. And some features can be hidden by using enhanced vMotion compatibility or compatibility masks. So it means that we can achieve enhanced vMotion compatibility across the host if they have some minor generation gap within that particular generation using the vSphere vMotion enhanced vMotion compatibility. All
Sir,
right.
the 1 gigabit, what is that word, sir? 1 gigabit internet network,
Yeah, that is for network, na physical network connectivity
a
between.
physical network. Okay, sir.
Yeah, correct.
This
So
one, sir,
normally you'll
quantum.
see nowadays like we go 10 GB or 25 GB of speed, so we don't need to be worried too much about that. Okay. So what it's trying to say here is, like for example, if this is my ESXi host, and definitely for ESXi host a dedicated VM kernel is mandatory to configure the vMotion, right? And the port
Yes,
from
sir.
here vMotion is happening to maybe another ESXi, same architecture is over there, then this pipe should be minimum 1 Gbps speed available. Does not matter whether it is dedicated or it is in shared way, but yeah, at least 1 Gbps network should be available. Okay. Anyway, you can do migration less than 1 Gbps also, but
Okay.
for better performance, it should at least minimum recommendation is 1 Gbps. Okay. And also 10 Gbps where we can perform concurrent 8
Okay.
uh, live vMotion migration. All right.
Okay.
So when we say the VM kernel networking, as I said, we have to create on each and every host a dedicated VM kernel port. Okay. Like in this is my virtual switch. We required a dedicated VM kernel port for vMotion function. Okay. And it use default TCP IP stack. When we say default TCP IP stack, that's what we are using as in my management gateway that use the same gateway. But if we wants to make the custom TCP IP spec, that also be created. What do you mean by custom TCP IP stack here is Probably remember when we are creating the vMotion VM kernel port, there was an option TCP/IP stack, right? And we have chosen that as default. But we can make a separate gateway and separate connectivity for especially for vMotion traffic. Okay. It means that like I have created a separate subnet, like for an example, 1.0/24, that is especially for vMotion network. And also for this particular subnet, there is a default gateway 10.0.1.1 would be my default gateway. So in this case, if I am using a custom TCP/IP stack, a separate TCP/IP stack for vMotion purpose, then we have to override the default TCP/IP stack setting, and we have to override the gateway IP address also that we are using for vMotion purpose. Okay. Otherwise, if we not change it, then my default gateway would be my management gateway, whatever I am using for management, right? Okay, so next is checking the vSphere vMotion error. So sometime we got some, like when we are choosing the target host while we starting the vMotion of virtual machine. So vMotion, simple vMotion of virtual machine, simply meaning is we are not changing the underlying storage. We are only changing the compute and memory from one host to another host. However, my underlying storage will be same, and that would be reachable from the source host and target host. When I say underlying storage, it means that like if there is number of ESXi hosts are available in my environment, and this is my shared storage, so this should be reachable. So when we only performing the vMotion for virtual machine, only my compute will be switch over because storage is already accessible. This virtual machine storage files are already accessible from my target host as well. Okay. But yeah, definitely if some restrictions, like for an example, target host is not accessible to this data store, then it will not allow you, or there is no target compatibility, like for from CPU perspective, or some misnetworking configuration. When we say misnetworking configuration, a VM kernel port is not available, appropriate VLAN are not configured, or some or some you see this error, vMotion interface is not available on target, so that time it will not happen. So it's mandatory to keep an vMotion VM kernel port for each and every host from where to where we are migrating the VM, because it will take if I will design here network topology, so it will use the vMotion network. This is my vMotion network, and under this there is always have a VM kernel port. All right. So without this, it will not happen. Or sometime host have some affinity rule to VM, then this VM will not move to target host. All right. So all prerequisites should be pretty much match whenever we are triggering the migration. A migration can be happen, vMotion can be happen of manual and automated. When we say manual, manual means we are triggering the right click on the VM, start migration. That is my manual migration. Okay. But if this cluster is DRS enabled, then a automatic vMotion will happen whenever any host field load, and also whenever we put host in maintenance mode, automatically the VMs are running on the host will be migrated. But again, all my vMotion prerequisites should be match, and it should be okay for each and every host the VM is migrating. All right, are we clear?
Yes, sir. One question I is faced in like in interview. One question. This means that they can able to like what to say migrate all the VMs to the other host, but for the one host they unable to migrate. But the VM is in like in powered on state, but they unable to migrate that VM.
To that
Why? What
one
is
of the
the?
host from the cluster, right?
Yes,
So
sir.
for that, there is affinity and anti-affinity rule. We will talk about that. So when any anti-affinity rule will apply between that VM and host, then that host will not accept any VM.
Okay.
Right? For an example, I have created anti-affinity rule. Any anti-affinity rule between this VM and this host, then it will not go to this particular host, and you will get clear message here. because of anti-affinity rule between this VM and host, not able to migrate this VM to this particular host. Okay. But if it's a simple error, it could be a error. A vMotion interface is not properly configured on target. But like if this host is accepting for another VMs for migration, it means that it is okay. But yeah, there is some anti-affinities configured between that VM and that particular host. Because of that, that's not expecting the specific VM. But if for all the VMs same situation, then there is some glitch in your network, or maybe that host have the different CPU configuration at home. That's not matching. Okay. There could be two reasons. If any VMs is not moving, a vMotion interface is not available, a CPU compatibility is not available. Okay. That's the reason for all the VMs. But if it is for a specific virtual machine, then there is some anti-affinity rule being configured between that particular VM and that particular host. That's why that host is not accepting the particular VM to be migrated on that.
What is this anti-affinity rule, sir?
We'll talk. Don't worry.
Okay.
That's coming. Yeah, that will be in VM resource management. We'll talk in detail. Just an high level, anti-affinity rule between VM and host is means that there is no relationship. That host will not accept that VM to be there. That is anti-affinity. And affinity is reverse, and this VM should run on that particular host only. We'll talk in details. But affinity is something, some affection between VM and host. Anti-affinity is they are not, the host don't want to keep that VM running on that particular individual host, that particular VM. Okay. Or maybe the group of VM also.
Sure.
We'll talk in details. Don't worry about that. That's in resource management. But just to answer your question, if nothing is accepting that host, maybe vSphere, vMotion, that host on different network, or if that's not accepting the particular VM only, then there is some anti-affinity rule between that VM and host. Okay.
Okay.
All right. So here is a small lab. Create a vSphere, vMotion, VM kernel pod that you know very well. Prepare for virtual machine for migration. Prepare means you just check on which host currently it is residing and how we are triggering the vMotion and migrating the VM, manual migration. Yeah, that definitely we will see. Don't worry about that. That we will do and some hands-on. Then what is EVC? Enhanced vMotion compatibility. Okay. So enhanced vMotion compatibility can be enabled for the entire cluster or can be enabled for particular VM as well. But before that, we have to understand what is the enhanced vMotion compatibility. For the compatibility of the VM that is running from one host to another host, these are some CPU characteristics. Those should be matched. All right. So for an example, CPU clock speed, cache size, hyper-threading, number of core. Is there any dependency? Answer is no. If between two CPU family, a clock speed mismatch, like for example, on one host CPU have 2.3 gigahertz, another host is 3 gigahertz. Will it stop migration? No. Cache size? No. Hyper-threading? No. Number of core? No. So there is no dependency on these factors. All right. So reason is being because VM is not talking directly to my underlying these devices because on my VM, all the resources are virtualized. Second, manufacturers, Intel or AMD and generation. Is it an applicable factor? Yes, it is an applicable factor. For example, if I will say on one host, I have CPU Intel, but on another host, I have CPU AMD. Can we do the migration? Answer is no, because it's an applicable factor. Presence of any instruction setting in SSE3, these are the CPU setting. All right. So if they are mismatched, then also my vMotion will not happen. Virtualization hardware assist for 32-bit VM. If there is a 32-bit VM, we are migrating between two hosts. Is there any conditions to if virtualized hardware assist is not enabled? No, that's not a dependent factor. But yeah, if it is a 64-bit VM on Intel CPU, then virtualization hardware assist feature should be enabled on both sides. Because Intel 64-bit with VMware implement with Intel virtualization VT. Intel VT is the CPU feature. So this CPU feature should be enabled on both sides in case of 64-bit VM, but 32-bit VM, it's not a mandatory condition to match. All right. So these all are the CPU conditions where my vSphere vMotion ignores some of them, but some of them are acceptable. Like this, it will ignore. It will not matter what is on source, what is on target. But this, it will be applicable. It will check. This, it will be applicable. It will check. From this 32-bit VM, it is not a applicable factor, but for 64-bit VM, it is a applicable factor. All right. So these are the some CPU compatibility functions. So when we say enhanced vMotion compatibility, what it means? It means is within a family of CPU same, like not in different vendors. Like, so sometime my CPU baseline is different for one of the host. So if CPU baseline is different from one of the host, then by default, it will not be the part of any migration because of again CPU mismatch. All right. But to make this CPU baseline as compatible on cluster level, we can enable enhanced vMotion compatibility. Right. Now you will ask, sir, can we do the enhanced vMotion compatibility between Intel and AMD? Answer is no. It is already certified CPU by VMware when we are enabling. So we will select particular generation like for Intel Xeon. So it will show under Intel Xeon which all are the CPU families can be, like this is CPU family 1, this is 2, 3, 4, all can be the part of under this Intel Xeon, all could be the part of this enhanced vMotion compatibility. It means that all related CPU to this family, if I have cluster, like for an example, this have CPU family 1, this have CPU family 2. If we want to make compatible with each other, then we have to enable on cluster level EVC. All right. And also this EVC can be enabled per VM level also. Like we don't want all the VMs should be migrate across the CPU family. So we can enable this per VM enhanced vMotion compatibility as well. All right, we clear?
This is a bit confusing for me.
No problem. No problem. Let me just repeat you again. If I should see from CPU ID perspective, I have one CPU, I have one host in the cluster. Just assume this host part of cluster. But by default, just because of this different CPU ID, like for an example, CPU ID 4, I am not able to migrate the VM because VM, my cluster recommend to keep the same CPU IDs. But to make this compatible, to make this separate host as compatible, you can enable enhanced vMotion compatibility feature. When we enable the enhanced vMotion compatibility feature, there is the list of CPUs. Under this list, these are the CPU family which can be the part of EVC. All right. So under that family, we can enable the EVC and we can make an host compatible from uncompatible for the vMotion function. All right.
Okay, sir. So
Yeah.
while we enabling the EVC features, so if any CPUs like or mismatch also, we can proceed the migration.
Correct.
Right?
Correct. But again, with mismatch, there is certain version only those can be compatible with each other. Not all. If you will say there is an Intel and AMD, can I do between EVC? Answer is no. Okay. If I will say this is Intel Xeon, this is Intel base CPU, then answer is no. But within Intel Xeon family, there is certain list are defined which can be where we can enable EVC. There is a list already, okay? But only we need to enable EVC as and when requirement. But if all my CPU IDs and all already matching, then I don't need to enable the EVC. Okay?
Okay.
Yeah. And this EVC compatibility can, I mean, if we only wants to enable for particular VM basis, then we can enable on VM level also instead of for the entire cluster. Then only for that, only those VMs will be migrated here and there, not rest of the VMs. Like out of 10, I have enabled EVC only for 2 VMs. So those 2 VMs can be migrated to mismatch CPU ID. The rest 8 cannot be migrated. All right.
Okay.
Yeah. See, normally it has not been seen, be frank with you, because whenever we make any cluster or something like that, we always keep the hardware same. Okay, so when we say the compatibility, CPU compatibility requirement, it always prefer to take your nodes from single vendor, all right, either from Intel or either from AMD, correct? Either from Intel or either from AMD, all right?
Yes.
Don't take different vendors. Then use Intel CPU with the this architecture, use AMD with first generation Optron, B enable hardware virtualization, any the host where we are installing hypervisor, enable these features on CPU level. AMD V, in case of it is in AMD CPU, enable from BIOS first AMD V feature. If it's a Intel, enable Intel VT feature. Okay. And there is another feature in AMD CPU, no execute, just enable this feature from the BIOS or execute disable from the Intel. These are the features with the same name available here. All right. So whenever you purchasing any ESXi and before installing ESXi, enable, in case of Intel, enable this feature plus this. In case of AMD, enable this feature and this feature from the BIOS. Or maybe those are already enabled, you have need to be verified first. Otherwise, near in future, you will get the vMotion compatibility and all issues. Configure the vSphere vMotion network. All right, that's mandatory. Applicable applications in VM must be CPU ID compatible. By default, all my VMs are the compatible with the CPU IDs that is available inside the Intel or AMD. So all these requirements we have to keep in mind. All right. So when I say to enable EVC, by default EVC is disabled for any of the cluster. When we enable, like you see EVC for Intel host. So I give an example, okay? For Xeon Core 2, if you are seeing this screen, all these families can be the part of EVC. All right. Under this CPU family, all these families can be the part of EVC. So here is a list. If you will find from here, you will get certain list of major list, and these are the minor for that. Here you will get some AMD as well, some another generation for Intel CPU as well. You will get a big list. So those are pre-certified CPUs from VMware. Between them, like this is major family and these are the minor family of this CPU. So under all these minor families, we can enable the enhanced vMotion. All right. So changing the EVC mode of CPU, several EVC mode approach are available in Ensure. So in host and cluster compatibility with newer EVC, you can change the EVC mode in existing enhanced vMotion compatibility cluster in running mode. You can enable EVC mode on cluster that is not pre-configured as an EVC. Later on you can, right? Raise the EVC mode to a CPU baseline with more features. Running VMs remaining powered on, but new EVC mode features are not available with the VMs until they are once restart. That's the important point, okay? So to identify the EVC functionality. If there were already some running VMs and we have enabled CPU EVC, either we have enabled in starting itself, or if later we have enabled, so the VM which were running already in the cluster, we have to just power cycle them to identify the EVC functionality. Okay. Lower the EVC mode to CPU baseline with fewer feature. So power of the VM, if they are powered on, running at a higher EVC mode than when you intend to be, intend to be enabled. So it means that is power of your VM, the power on and running it later. If there is higher mode of, what do you understand higher? Like for example, today I bring a CPU for like Gen 1 and tomorrow I'll bring two CPU for Gen 2. All right. That have the, okay. So this is for fewer. Fewer means is less feature. So less feature है तो भी आपको powered off, then you have to powered off and power on. And this is compatibility where CPU have more feature. Means there is two mode. Either my new CPU, like for example, there is the host we are already running a cluster where we are trying to add one more host in the cluster. There could be there could be two types of CPU, either higher generation or lower generation, correct? So in case of higher, it tell for existing VM, the VM which running existing one, we have to take power cycle. And lower CPU, yes, definitely we have to power off and power on the VMs. There could be both cases, right?
Okay.
So virtual machine EVC mode, that's what I told you. You can enable the EVC mode again on independent virtual machine level also. All right. Then it comes from 6.7 onwards. All right. So yeah, VM level EVC, the primary use case normally when we, like for an example, today I have a cluster and tomorrow I build a new cluster and we want to migrate those VMs from here to there. All right. So that case, maybe another CPU families are available. So for them, we enable the EVC on the VM level, the VM which we wants to trigger from one cluster to another cluster. All right. And also within same cluster, whenever we see, we need EVC for the specific VMs, not for the entire cluster, not for the entire set of VMs. Those are running into the cluster. Got it?
Okay.
Okay. So there is some CPU identification marks. So when we say CPU identification mask, CPU IDs, all right. So in manufacturing, you see no execute or execute disable. So these identification marks should be when NX means no executable or XD. See, these are the same feature, but name are different. If you will say no execute or execute disable, end of the day answer is same, correct? But the naming convention is bit different. When it is Intel AMD, this name will come like this. When it is AMD CPU, this name will come from no execution. So NX is the short form of no execution. XD is execute disable. So end of the day meaning is same, but in different CPU family, the features come from different name. Okay. So when NX means no execute, XD execute disable. PIT is visible to guest OS. VM can use this feature, but you can migrate the VM only on the host where feature is enabled. Simple meaning. If take one example, I have two AMD hosts in the cluster where on host level, I have enabled this feature. Enable means I have configured no execute. All right. But here I have also configured the no execute. This is on BIOS, CPU BIOS, physical BIOS. When my VM is available here, all right, it will always observe this factor. If no execute is enabled here, then on target, no execute should be enabled. All right, this is monitoring that bit. Take another case where I say no execute is enabled here, but no execute is not enabled here. So when I will trigger the vMotion this time, this vMotion will not happen because of CPU masking configuration mismatch. All right, got it? Are we clear? Yes, no?
Sir. Yes, sir.
Yeah. All right. But
first, if there is no execution on the both hosts, the VM will be migrated. If there is no in one host and another is
if there is any
and
mismatch, VM will not migrate. Simple. All right.
yes,
Second case is if on this VM we have this masking, we have disabled. Okay. If on the VM level we have disabled this masking, it means that it will not care. It is a match, underline match or underline mismatch. So that point of, because masking have been disabled on VM level, so this VM will not take care of this CPU feature. All right. But if this masking is enabled on VM level also, it will always trigger the underlying feature also. That point of time, there should be always a match in the underlying configuration. Okay. So same rule apply for Intel. I took you one example of AMD CPU. In Intel, its feature is come XD. So in case of Intel, the same feature should be applicable. All right.
Sir,
Got
if
it?
the VM we didn't disable those features means it's the migration is possible, sir.
If on VM level,
VM
we
level.
have, yeah, correct. If there is a mismatch, then it is also possible. But if VM level, this is enabled, there should be always a match.
Okay.
Right? But again, on VM level, if it's a disabled, does not matter it is matching or mismatching. VM not reading the mask, underline CPU ID mask, it will be migrate. Got it?
Okay.
Yeah, it's a simple thing. If I have by default this is enabled, if there is mismatch in this configuration underline host, then VM will not migrate. If I'll disable on VM level, if there is enable or disable, it is not a matter for VM because VM not monitoring that factor, mask, CPU ID mask factor. Okay. So that could be another reason for your question, Shiva, you are asking, right?
Okay.
Yeah, if there is a CPU ID mismatch, then it may be a cause your VM is not moving for particular host. All right.
Okay.
So as I said, on the host level, these features are enabled from the BIOS, and on the VM level, these features are available in VM option itself. I'll show you when you will expand the CPU, then you will see CPU ID mask, match, enable or disable. Enable is check, disable, uncheck is disable. Okay. All right. So lesson 6, 7, where we are talking about on storage migration. When we say
So what is the
storage,
benefit of enabling?
enabling is always secure.
Okay.
Yeah. So, and again, I would say if it's a 64-bit environment, it's mandatory, right? If it's a 64-bit environment, these enablement
Okay.
is mandatory. Otherwise, you will not be able to migrate 64-bit VM any place. You see in this previous slide, na? I told you here, this one. ये आपके लिए mandatory हो जाता है feature enable करना. ये
Okay.
नहीं.
Suppose that
हाँ, CPU
on
ID.
the host it is
हाँ.
enabled. Okay. And we have disabled on the virtual machine. So virtual machine will be not migrate, na?
अरे नहीं यार, ऐसा नहीं है. अगर वर्चुअल मशीन लेवल पे डिसेबल किया है तो आपको डज नॉट मैटर आपके होस्ट लेवल पे इनेबल है डिसेबल है, वो मैच नहीं करेगा सीपीयू मास्किंग को. दैट्स व्हाट आई एम ट्राइंग टू टेलिंग.
There are two ESXi hosts. Okay. On both it is disable, but on the virtual machine it is enable.
देखो आप ऐसे कंफ्यूज मत हो. लेट मी एक्सप्लेन इट अगेन इन ए सिंपल वे. नो
So right
एग्जीक्यूशन.
here disable.
हाँ, वही मैं केस ले रहा हूँ. ये वीएम तो वीएम पे कोई फर्क ही नहीं पड़ेगा फिर. देखो अगर वीएम पे, अब आप क्या कह रहे हो, इसको ये डिसेबल है यहाँ
No.
पे,
Yes.
right?
Yes. Disable. Disable.
तो यहाँ
Disable.
पे या तो
Disable.
ठीक है.
Disable.
हाँ.
And on the virtual machine it is enable.
हाँ,
What
then
will be the
it
impact?
will migrate because this disable is matching here na.
Okay.
It is a
Okay.
match.
Okay.
But if you will say sir here is enable, here is disable, on VM level it is enable. Now this VM will read this feature. If
Mm-hmm.
it's a mismatch, then it will not migrate. Got
If
it?
it is disable, also it will not migrate.
अरे नहीं यार, कहाँ पे डिसेबल?
On the नहीं सर, नीचे इनेबल है ESXi होस्ट में, एक में डिसेबल है. ऊपर वर्चुअल
हाँ.
मशीन में अगर इनेबल हो
हाँ.
गया तो भी नहीं माइग्रेट होगा, डिसेबल हो गया तो भी नहीं माइग्रेट
नहीं
होगा ना,
नहीं,
क्योंकि
डिसेबल
मिसमैच हो
होगा
रहा
तो
है.
माइग्रेट होगा. क्यों नहीं होगा? डिसेबल में तो वो डिसेबल में तो वो देख ही नहीं रहा ना नीचे के फीचर्स को.
अच्छा.
इज नॉट चेकिंग
Okay,
अंडरलाइन.
okay,
Enable means it is
okay,
checking the underlying feature. If there is a mismatch, it will not migrate. Disable means it is not checking underlying feature. Does not matter
okay, okay,
what is setting here, it will migrate any cost. Got
okay,
it?
got it.
Enabling and disabling VMs means it is checking or not checking. Okay? Enabling, disabling on host level, it is actually we are enabling some feature. Got it?
Got it.
Clear now? Okay.
Clear.
Yeah. So in storage vMotion, when we say storage vMotion, it's simply think we are just moving the underlying storage from one host to another host. However, my VM will keep on running on the same host. That is my storage vMotion. All right. And if we'll say both, when we say both, it means that my VM is also migrating from one host to another host, and underlying storage is also migrating from one data store to another data store, right? So is vSphere storage vMotion possible in vSAN cluster? Answer is no, because in vSAN we always get a single data store across the node. So vSphere storage vMotion is only possible use case whenever we are using SAN or NAS and we are using number of data stores or shared data stores are connected to my ESXi hosts. Okay. Then only this storage vMotion case possible. When we say both means we are migrating the VM from one host to another host, also the underlying virtual machine storage from one host to another host. Okay, clear? Yes, no? Are we good?
Yes, sir.
All right. So these are the storage array APIs that is being primarily identified. So if there is some like USB device and all, these are not supported for the only we'd say the shared storage is part of this, or the storage that is connected to host directly, kind of disk. But if it's a USB drive, CD-ROM, USB, these are not supported source for my vMotion, for my storage migration. All right, so plan, coordinate, individual virtual machine disk should be in persistent mode. If there is some, but these are the virtual machine setting. If it's say persistent mode, it will not be migrated. Here is some lab. Yeah, definitely we will perform storage vMotion and both. Then virtual machine snapshots. What is virtual machine snapshots? So I won't take much time on it, mostly 5 minutes. It's very simple. We normally prefer to take the snapshot whenever we are trying to make any change inside the operating system. And we are in confusion whether that will be applied or not. Suppose today I have a virtual machine and this virtual machine is using a 1 terabyte hard disk. All right. So I have a plan activity for individual host to be patched. All right. So for that, what I will do, I will take a snapshot. Snapshot is my current machine status being saved. So whenever I will take a snapshot within this 1 TB, it will create a small delta disk file. Okay. And after taking a snapshot, I have started the patching. Okay. So when I have started the patching, this patching got 2 GB space. So this 2 GB changes will be stored here and this file will become 2 GB now. All right. Okay. Next is after 2 days, I realized that this patch is okay and I want to continue. All right. So then what you can do is from this is my snapshot. Currently, you are, whatever from the day you have taken a snapshot, anything you are doing that is being saving here in this delta disk and it is getting increasing accordingly the data you are writing. Let us suppose now you have 2 GB patch plus 1 GB of your data. You say after today, sir, I am okay. That's not a problem. So what I can do is I can go ahead and delete the snapshot. When I will delete the snapshot, automatically this 2 GB, because this 2 GB was in under this will get merge here. This will get merged and I won't have more snapshot available. All right. And my changes will be merged in my parent disk. Second case, you say, sir, I have, after a snapshot, I have patched my Windows server, but I didn't see the exact behave. I have some problem with the operating system. So in that case, what you will do? You will revert the snapshot. Once you will revert the snapshot, like today you are working here, you will be trigger the time whenever you took the snapshot and your VM will go on the stage. Let us suppose today I have taken a snapshot, or yesterday probably, I will say yesterday, today I am on the stage after patch 10:30. So it will go back on the same state whenever you took that snapshot. Okay. Your working condition. All right. And later on, you can delete this snapshot. First revert, then delete. It means that it will not accept the changes being done post that snapshot. Are we clear? If we are accepting the changes being made after taking a snapshot are acceptable for the VM, I am okay to drive all the changes, patch and whatever configuration you have done, then you go ahead and delete the snapshot. All the changes being made from the day of snapshot will get merged and you will be on the current stage to working in your virtual machine. Another use case where you say, sir, yesterday I have took a snapshot, I have patched my machines and all, but I feel it's not good. There's some problem. I don't want this patching data more. So first you just revert to the place where you feel okay, means on the stage of it. Then you delete the snapshot. Then those changes will not be merged on the parent disk. Are we clear? Yes, no?
Yes, sir.
All right. Yes, so so after taking snapshot, delta disk will be created, right?
Absolutely. After each snapshot,
And
maybe we can have a
yes,
chain
and
of snapshot also.
and whenever we write anything, it will be on delta disk, right?
Delta disk, absolutely right. Or if someone asks, can we create more than one snapshot? Yes, that's absolutely possible. Maximum limit is 32, but normally people don't go. Like here, you see an example. There is a base VM. First snapshot have been taken. Then one more snapshot have been taken for the security patch 1.2. So now it means that in this chain, you have 2 snapshots right away. Okay. So you are working on second delta disk. Okay. So now your series is like it. Now what you have is, you from disk's perspective, the underlying disk, you have a base disk, you have a delta disk, but again you have one more delta disk. The day you have took a snapshot, then you have patch first. So patch first here in this delta. Again you have took a snapshot, patch 2 here. So now whatever you will write after patch 2 as per this picture, this delta will get increasing day by day until unless you will not revert or you will not delete. Okay. Because your latest stage is here. All right. So snapshot of virtual machine memory. When we say the memories means that is when we took the snapshot, when we say virtual, whatever the data is available being in current condition in my memory, whenever I will revert, it will give me the same state. Which the guest files need VMware tool, VMware tools install होना चाहिए, और जो आपका files भी आपको operating system में whenever you feel some files were running there, some files were opening or close, or at the time you were taking a snapshot, those file will be in the same state back if you will select. But yeah, definitely if you select the second option, it will take some more time as compared to the normal snapshot taking time. All right, a snapshot capture not include any independent disk. When we say independent, there is a disk type. Normally my disks are dependent, persistent and non-persistent mode. That is the limitation. All right, so when we create, yeah. Yes.
While taking snapshots, sir, there is a check the standard, the virtual memory is there, sir?
Yeah, we can keep
There
that.
is a
That's not
tick
a
mark.
problem. But yeah,
That,
taking
yes,
quizzing
sir.
state, it
If we
always
not
takes impact.
check that one, yes, sir. If we not check that one, then
No
also we'll take a
problem.
snapshot.
So whatever content in memory that will not be safe for the moment, it will take the last best state.
Okay. If we enable that one, sir, the memory, it will take the whole,
Yeah,
whole
whatever
like whatever.
whatever execution was happening on the memory. So when you will revert it on that place, that will be start from there only. Your memory contents would be available there.
Okay. It's like kind of a backup right now, sir.
Backup is not exactly the backup, but yeah, the level of configuration you are doing in Delta, because snapshot is just saving that state. But like for an example, after taking a snapshot, you have deleted something that was available before snapshot. You cannot recover that.
Okay.
Get my
After
point?
taking the snapshot, if you delete anything, it won't recover, sir.
Whatever there before snapshot.
Okay.
After a snapshot, if you create something or you delete something, that will be recovered.
Okay. Okay.
Yeah, it's not pure backup. That's why we don't use it for backup. So whenever we will take any snapshot, these files will get created. One Delta VMK always create a sparse disk where we are, saving the data, and vSAN sparse for vSAN. A Delta object will get created with the name of -vSAN. And there would be a state file also that's we called as an VMSD. VMSD will just update the states like it is snapshot 01, snapshot 03, snapshot 04, kind of that. You can see here, these are the files what I was talking about. Like here it is showing VM10-03. It means that there is a third snapshot. All right. A 3VMDK, a snapshot state file, and a delta file. Okay. 01, 002, 003, like the way. So these are the main file: configuration state file, memory state file, .vmdk, just a descriptor, and delta is your where actually you are storing the data, and sparse disk are your the delta disk where you are storing your data.
Yeah, VMDK, whenever we create a virtual machine, a VMDK, this is
.vmdk,
first.
see, normally तो किसी for each and every disk there would be a VMDK.
Yes, yes.
Yeah, that is just descriptor file. That is not actually my data saving file. That's not storing. That is just descriptor. This have the metadata about your VM. All right. So when
And
you
all.
see VM with no snapshot here, so this is the current state, right? There is no snapshot. So normally you will see these kind of disks files are available. But when you will take the snapshot, like snapshot 1, these new files will get created: memory state, sparse disk, delta disk, descriptor file. All these new files will get added. All right. Again, you will create a new snapshot. A set of new files will get created. Okay. You see here, VMSN is created, sparse is created, VMDK is created, because memory state you have already been taken. So here you could see with memory, but here without memory. But if you will take again with memory, then again .vm snapshot to vmem file will get created. Okay. So how do we take the snapshot? Right click snapshot, take a snapshot, and how we manage the snapshot from the manage snapshot console. And we can keep on doing.
Sir, if suppose after taking the second snapshot, it's fine to delete the first snapshot, sir. That will won't affect the this one, sir, because already
That
we
will
have a
not
second snapshot.
impact. What will happen? Whatever delta is available here, it will be merged here. Like for example, this is my delta disk. Here I have created first snapshot, and in this first snapshot I have 1 GB data. Second snapshot I have 3 GB data. If in case you are deleting this directly, no problem. It will be merged here. Then your new picture will be like this. Okay. Got it?
Got it.
All right, so VM snapshot consolidation. So when we say snapshot consolidation, so like as I said in previous example you were asking, whenever we delete any snapshot, all delta files and all, it merge with the parent disk always, whatever the next parent. If due to some reasons and all, my snapshot have been deleted, but my disk is not merged so far, it is showing me as a delta disk. So from the VM console itself, I can run VM consolidation. So when we say the consolidation, it will merge my delta VMDKs to its parent disk always. Parent is always under the snapshot disk is available. Like in this example, by default, in this case, for this delta, this is the parent. For this delta, this is the parent. So whenever I will delete this, it will merge here. It will not directly merge here. Whenever I will delete this, it will merge here, not to bottom and not to up. Correct? So if in case this merging not happen after a snapshot, so you will say an alarm consolidation is required, then you will go individual VM and consolidate the snapshot. Consolidation means just merging your delta disk to the parent disk. Okay, so like when you say warning snapshot, automatically consolidate option is enabled and you can do that. All right. So can we delete all these snapshots together? Answer is absolutely yes, we can. It's all matter on the environment and the pictures, like how do we want to flare. Like this one is snapshot. This is snapshot 1, for example. This is snapshot 2, snapshot 3. So when you will go snapshot management, you will get 3 tabs: revert, delete, delete all. So currently you are here. All right. So if you will say revert to, if you will revert to, like for example, you revert to S2, it means that after S2, whatever change is being made, that will be away. All right. Got it? If you will say delete that bottom one, so what will happen? Whatever changes are here, that will be merged here and S3 will not be available more. Okay. Same way, if I will delete all together without reverting, it means that we are accepting 1 GB change here made, 1 GB change here made, 1 GB change here made. All these my deltas will merge here, and whatever changes being made, all 3 snapshot, those will be available inside my virtual machine. So it's all depend upon condition to condition how we need to do. But normally we have seen we don't make the longer chain of the snapshots of the virtual machine. We just keep one and just for maximum 72 hours and all two, because we don't want to increase delta too much. Whenever we'll delete, it will take time of synchronization with the parent disk. Okay. Normal recommendation is keep one snapshot and just delete that. Take the decision either revert or delete it. Hope you understand the difference between revert and delete. Again, I'm repeating. If you take a snapshot here, this is my delta and you don't want change, first revert it. Once you will revert it, no change will be there, then delete it. If you want those changes should be merged, then directly delete it. Got it? We clear? So these are some lab from the snapshot perspective. So now I'm closing the theory part and let's jump in some lab environment and let's perform some labs there. All right?
Yeah, okay. Here we can also see that after taking snapshot, delta disk will be created.
You can see everything. Okay. Don't worry. So let us perform some labs around vMotion first. Then see this compatibility check also. Okay, so for that you have to allow me some minutes so that I can log in some lab environment and can solve issue right away. Okay. So these are the labs we are going to perform with the VM kernel. You are pretty much aware already. I don't need to create more. Can I stop this recording and make the new one for lab purpose? Will that be fine?
Yes, yes. Yeah, it will be fine.
So that we should not have too lengthy recordings. Okay. Stop.